Hi everyone, and welcome back to episode 2 of our series Music and Patterns in Tidal Cycles. So in the first video, we covered all of the basics for how to create patterns of beats, what algorithmic music is, how to make patterns that changed over time, that had elements of randomness that are kind of unique to making music with computers. And so now this time we are going to start talking about things that are useful for making melodies. So we're going to start with a very simple piece of code. So this is just once per cycle, we are playing a synthesizer that sounds like a piano. And let's stop that for now. Now, that's pretty boring. And before we talked about how to have multiple events per cycle, so we could do something like this. But unlike so with our drums, it was okay to have the kind of same drum sample hitting again and again and again. In this case, you don't want that for a melody. You want to actually change the notes over time. And so we're going to spend a bit here talking about how to do that. And we're going to write a slightly different piece of code than what we had before. And we're introducing some new syntax. And in particular, we're showing how to so we have this stuff with the dollar signs. And now we're showing a new thing that involves a hash symbol. And the reason for this is that Tidal has kind of a notion of you can make patterns and then you can also modify patterns. So when you're reading this, is the thing that comes just after the dollar sign, N, in this case for notes, FACE, that's saying a pattern of notes. And the pattern of notes is going to be an F, an A, and a C, and an E each cycle. Now, we haven't defined what the instrument is for that. And so we want to modify the pattern of notes by saying, well, we want to describe a particular instrument that should be playing those notes. And so we modify it with this pattern of sounds. And in this case, it's just one sound because we only want one instrument for all these notes. And if we were to try this now, so there's the little note progression, as you might expect. And you can basically think of the difference between the main pattern you're creating and then the things that are separated with the hash symbols. You can think of the things with the hash symbols as like adjectives. And so we want to go from here. We're going to be introducing a lot of these kind of adjectives and ways of modifying patterns over the course of this video. But first, before we get there, we want to do something a little more complicated with this melody, right? Like we want to do something a little more along the lines of what we had before in terms of like more complicated rhythms and cadence and things that change between cycles that maybe even have a little randomness. So with the same tools we had before, instead, we can type a slightly more complicated thing. But part of that, before I actually do that, we have to talk about the fact that you can choose a bunch of notes, right? But they're not necessarily going to play well with each other. They can kind of sound off, maybe a little sour. And the reason for that is because we sort of have keys, scales, that every tradition of music has some sense of like like what notes tend to go well with each other, and this is how like instruments are tuned, and there's a lot of deep theory there that we're not going to get that much into, especially since a lot of it is very like centered around like your particular like European traditions of instruments and stuff. But I will say that you know, the notes of the normal like scale you may have seen if you did like music classes, you know, C, D, E, F, G, A, B, that's the C major scale. There's a variant of the major scale, the Mixolydian mode, that goes C, D, E, F, G, A, B flat, and then to C again. And so there's a bunch of these different things. We're all going to kind of play with them for a bit. But for now, we're going to just stick to C major, so just the C, D, E, F, G, A, B. And rather than type it all out, I'm actually going to grab it from where I wrote it earlier and just copy, paste over. This is one of the wonderful things about doing algorithmic music, is that you can copy and paste. So now we have something that uses the question mark we saw last time. It used the angle bracket syntax to make distinction, like make things change over time. And we can just listen to this kind of quick. So I don't think that's bad. It's also not, it's not great. And there's a few things with it. First, I think it would sound better if it's a little slowed down. Basically, a little spoiler, by the end of this, we're going to be going for something that sounds more like the piano you would expect to hear in, say, like some lo-fi, you know, beats to stay to type of thing, right? Where you just have like kind of a quiet piano, and we're going to get there over the course of this video. So the very first thing is we're going to slow the pattern down. Well, how do you do that? Well, there's a transformation on patterns called slow, and slow takes a number that's the factor to slow it down by. And since it's a transformation on a pattern, which means that it takes the pattern and then turns it into something else. It's not an adjective type of deal. It literally just makes the whole pattern and stretches it out rather than changing some property about it. So now we can hear. And I'm starting to break things onto new lines just because as we change more stuff, it'll be easier to read as we do that. So this is still sort of okay, but one of the things I notice is it doesn't really sound like a piano very well. Like a piano, like the note tends to hang in the air, right? It's not plinky and like that. That's more sort of like a little toy piano sound. Well, there's another adjective, a modifier we can use to change it, and that's sustain. And sustain takes a number of seconds. The note should hang in the air and kind of decrease, you know, fade out gradually. So if we say sustain 4 seconds. So that's already a lot less thin, and we can keep doing better. And one of the first things we can do is add a little resonance. Resonance, sort of an echo, that is with the room adjective, the room modifier, which takes a number between 0 and 1, with 1 kind of being maximum echoiness and 0 being none at all. And by default, everything is at 0 room. Now, I'm going to change one thing else right away, which is that I'm going to make the volume smaller and using gain. The reason why is because as you add resonance, as you add sort of an echo, things get louder. So I want to protect all our ears and then just preemptively make it a little quieter. And if I need to turn it up, I turn it up. So I think turn it up just a little. Okay. that also is already sounding a bit better. And if we really want to go for that hardcore, lo-fi beats kind of sound, where it sounds kind of distant, it sounds like almost like an old recording you're listening to, part of that is a low-pass filter. A low-pass filter cuts out like the higher end of your frequencies, and in other words, like the high-pitched part of the sound, it tends to like filter out and then leave the lower part. And so we're going to add a low-pass filter here. So it's a pretty dramatic difference, right? Like it goes from being maybe a little tinny in those high notes there to suddenly being a lot more sort of that echoey, ambient, very chill sound. I'm just gonna stop it for the second. And so one of the other things that we can do here is add some kind of chords. Now, to do that, there's a couple of ways to do that. I'll show you one first, and then we're actually going to talk about how to solve a slightly more complicated problem. That's kind of fun. So the very first thing to do is, one of the important things here is that, and the reason why I brought up like some music theory ideas and that we're in C major, is that there are ways to describe the chords that correspond to the different notes. So we want the chords of C major are C major, D minor, E minor, F major, G major, and A minor. And technically also B diminished, but we're not actually going to use that here. And so if we want to add a couple of chords in here and stay in key, we can do. So let's have our first part of the pattern be a chord, and then let's have there be, when it hits the F in the cycle at the end of the pattern, when it hits the F in the iteration, at the final the final part of the pulse, let's have that be an F major chord. So let's hear this now. Of course, there's a lot of things we could do to this. We can make this even slower and floatier. But I'm going to keep it down at just slow down twice from the normal speed of the pattern. Now, what if we want to have chords, but only like sometimes, like have the chords be a part of the randomness? So this gets interesting, right? Because you can't just have, you basically can't just say, oh, well, do the major chord on a note sometimes, as some kind of transformation out in front of things. That won't work. You need to find some way of keeping everything within the same key. And this is where we're going to introduce a little bit of a different way of writing notes. So if you're super familiar with like the normal thinking about like notes and scales and stuff, all of that notation is built into Tidal, and I didn't say this earlier, but when I'm not writing the octave number, it's just assumed to be like the octave starting with middle C. So C4, through B4, and that's this, that's what all these notes are. Now, the other thing we can do is there's a function called scale. And scale takes a pattern of numbers and the description of a scale, like the name of a scale, and maps those numbers onto the scale directly, and keeping everything still in key, right? So we can use this, we're going to use this to make sure that we're not thrown off by the difference between, well, okay, which notes are major or minor or diminished, or in other keys, augmented, or all of these other sort of music theory things that, I think we can, as if we're doing programming, we should be able to get around some of that. So rather than deal with the notes this way, and again, I'm going to copy, paste something in here, because I think it will make stuff simpler. And if you're wondering what I just did with the double dash, that's a comment, which means that it stops being seen as code. It's just seen as sort of text that doesn't mean anything. And this helps us make sure that we're not evaluating it. So I'm just going to take out this line super quick and move this over. And so this is going to be the same thing as what we had before. The 0, we're saying it's major scale, and we're saying it's 0, which is C, and similarly, and here, let me go ahead and kind of move this onto this next line so you can see I'm going to take these out. In fact, I think the easiest thing, just to keep the code clean, is I'll move this up above. So we have our C is 0, and then D is 1, E is the third note, so that's going to be 2, since we're starting counting from 0. And this is a thing, if you haven't done a lot of programming, you count from 0 a lot. 0 tends to be where things start. So you don't count 1 through 10, you count 0 through 9 in order to count 10 things. And that's going to be important here. So we have E is 2, D is 1, A is 5, C, that's 0 again, our E is 2, our F is then 3, our AB is 5, 6, and then the G, F, E at the end, 4, 3, 2. And so this is the same. And let's stop that again with hush. Now, if we want to add the chords, we're going to use a transformation called, and only have it on certain notes, we're going to add a transformation called sometimes to transform the pattern of notes inside this use of the scale function. So what we have here is we're applying scale of major to take a pattern of numbers and turn them into notes proper that Tidal knows where they are. But before we do that, we're going to take the pattern of numbers and we're going to do a couple of fun things to it. And this is actually where I'm going to copy paste again and reformat things just a little bit to make it more readable. Now, what we have here is that we're introducing a couple of transformations. Sometimes does things only half the time, and there are also like often and rarely that function at different rates even still. But sometimes operates at, does whatever transformation you give it half the time to each note that comes in, each event that comes in. In this case, what we want to do is take the note and also play the third of the chord and the fifth above it as well. So that means, we want to play, because that's how the chords are structured. We want to play the 0th, we skip the first, we play the second, we skip the third, we play the fourth. And that corresponds to both the, the major and the minor and the diminished, because it turns out this is it's one of these things that makes more sense when you're dealing with code than written music. All of those ways of describing chords, they're just all the same thing if you're doing it this way, where you're dealing with numbers and then transforming those to fit a scale. So now, and what we're doing here is we're saying superimpose, which means that play this at the same time. And what are we doing when we're superimposing? We're taking the original note and then adding 2 to it and adding 4 to it and playing that 2 and that 4 at the same time as each other. So that means we're going to be playing 3 notes all at the same time. So as another example, if you need another little example of how that comma works, we can show you with just a little rhythm here. And we're actually going to introduce the concept of a polyrhythm. This is a cool thing we'll come back to, but we're going to play 4 bass drums and 3 bass drums at the same time, and you'll hear this rhythm. Sometimes it's called the pass the stinking butter rhythm, is among other names. And so it's actually playing both of those rhythms at the same time as each other. And you can do this for all sorts of pattern creation. That's the comma basically just means have these things happen at the same time. So now we can test this out. And what we should hear is that about half the notes will get a chord on them. And I'm going to turn down the low pass filter even more. Some of that lo-fi kind of sound to it. It's definitely the sort of thing you could use as the start of a longer piece, and it's a pretty easy melody to put together. And one of the advantages here of doing things this way is that now if we wanted to change our scale, we actually could do that super easily without having to think very hard about it. So if we wanted to change it to minor and be prepared, this sounds a little different. If you're like me, you actually have to let it go for a few seconds to let the new scale sink in without it sounding off, because your ear is still expecting the old scale. But here's one of my favorites, the minor pentatonic scale. It's one of those things that just kind of always sounds good, in my opinion. So again, just to review what we've done, we've taken a transformation called sometimes that does things, well, half the time, it does it sometimes, and then we're using it to apply this other transformation, superimpose. And what superimpose does is you give it yet another transformation, and it implies that on top of the event that it's changing. So this is going to, if I were to take away the sometimes, then things would always be chorded. Because for every note that comes in, it's going to take that note, play the 2 higher and 4 higher from that note at the same time, and it's then that gets changed by the scale function to being the right level of notes, and then passed to the end function that then actually turns it into Tidal's understanding of notes to send the superpiano synthesizer. So that's one thing that's kind of fun about Melodies. There's another example that I want to go through before we end things that I think is at least somewhat instructive, and that's taking that's arpeggiation. So we're going to cover that next. And so essentially, arpeggiation, if you haven't heard the term before, is you take chords and then you turn it into, you play the notes in the chord, except that rather than playing them, at the same time, you play them in a quick sequence from each other. So rather than, say, playing the, C, E, G for the, so rather than doing something like saying, playing C, E, G in the, C major chord, you would play C, E, G, just quickly, one after the other. And we're going to use this as a trick to create kind of a lower bass line and then a higher pitched melody on top of it, and kind of have these two related to each other. So we're going to, for the moment at least, go back to the other way of writing the chords and notes. And I'm just going to copy and paste this over. And one of the so reading this pattern, we have that the C3 major, so we're each, you can see the whole pattern is wrapped in the ankle brackets. So that means the first cycle of the pattern, we play the C3 major chord, so down an octave from what we were doing before, the E3 minor chord on the next cycle. Then the cycle after that, we go F3 major, D3 minor, play both of those in one cycle, so a little faster, and then the G3 major chord on the fourth cycle. And we just go through those, and we're going to use all the same like adjectives we did before with low pass filter, except we're room, sustain, the gain. We're also using something called shape too, which allows us to change a little bit how the synthesizer sounds. It sounds a little richer, a little thicker at a gain of like 0.3. If you put it closer to 1, don't put it actually at 1, but if you put it closer to 1, it's going to sound a little more distorted and weird. But so here's our pattern. Turn down the gain a little and turn up the shape just so you can kind of hear it. some weird resonances happening. Like it's like the echoiness of the notes doesn't sound quite right. It's a cool effect though, and it's worth using in a lot of circumstances, but not for what we want to do here. So now what we want to do is take this same, basically, more or less want to copy paste again. And if you're wondering, is there an easier way than doing copy paste? Well, we'll talk about that in the next video. But yeah, so let's assume we have this. Well, arpeggiation, is that going to be more of an adjective or a transformation? Well, since you're doing something to each event in turn, rather than sort of like the whole pattern, that's more of a transformation, which means it's not going to be something that goes down here, it's going to be something that goes in another, set of dollar signs, separating out all the transformations happening. So here, we're going to arpeggiate, and we're going to actually have a pattern of arpeggiation, because there are different ways to arpeggiate. There's up, which is you take the notes of the chord and play them up. There's down, which is the other way, you play them from the top down. And then there's, here's another, up and down, which is you go up, so for example, you would play C, E, G, and then G, E, C, like, so boop, 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 boop. And that's the up and down pattern. So let's just see how this sounds. And we don't want it this low though, like we want it to be higher pitched than the kind of baseline chords we're riffing off of. So to do that, we're introducing another transformation, which is this thing. And it's the pipe symbol, which is the pipe symbol on your keyboard, and then plus. And what this does is that it allows us to take everything in the pattern and then apply some numeric shift to it. In this case, we're changing the notes. And as we're changing the notes, well, why 12? And if you've played a lot of instruments, or if you've had someone like, you've watched like music theory videos on YouTube, you might know the answer is because we're dealing with semitones, and in an octave, there's 12 semitones. And so basically the idea of like all this scale stuff we've been talking about, if you haven't seen it before, the idea is that you're choosing an octave is choosing 8, it's basically choosing, well, really 7, because it loops back around. 7 notes that are out of the 12 notes that are inside every octave. And it's out of those 12 semitones, you're choosing 7 of them. And you're using those as your notes, and you're choosing them so that they work together well and they play well together. And so if you want to, if we're not doing things like using the scale function and all of that, instead, the easiest thing to do is to use a transformation like this, and there's equivalent one for minus, and then just up or down by 12 or multiples of 12. If we wanted to go up super high, we could say, pipe plus 24. And since this is a transformation, we're putting it between another set of dollar signs. So now let's try this. Just for fun, let's see how rough it is if we go up another octave. It's not too bad, probably because we have the low pass filter. So let's hear how high pitched it is without the low pass. Oof. I don't know about you, but that's a little. high for my taste. So if we just shift an octave up, this is what we get as our little melody based off of the chords. And we can combine these together. So I think that's pretty good, but there are other things we can do, and the last thing we'll mention here is that there is a transformation called swing, and swing adds a little bit of a shift to the notes, but only at certain parts. And without getting too much into the details, what we're going to do is we're going to do swing in 4, which means that we're kind of dividing up each cycle into 4 parts as we determine which parts to kind of shift. And if we do that, so that is, I think, a halfway decent melody so far, and kind of, chordy bass line. I feel like it's something that we could build as the backing to some kind of lo-fi track, and add in a good little set of drum samples, put some filters on those to make them sound a little echoey, and pretty slow. And yeah, I think you could easily build this into a track. And at the end of the day, it's actually not that much code, and just a few tricks building off of things we've seen before. So I think that's going to do it for this video. Next time we're going to be talking, we're going to be making some chiptune sounding music, and we're going to be looking at some more sources of randomness and transformations, and introducing the concept of continuous patterns, and some of the other one of the really fun tricks that algorithmic music makes easy, and that's Euclidean rhythms. And so we'll have fun next time, and until then, have fun, experiment making music, and we'll see you in the next tutorial.